So it's my honor to present my group, my team, to here to have a progress report about the Oryza nivara genome sequence. So our plant material is the only annular AA rice in Asia, and as you can see, if you remember the slide of the Dr. Win's. The genome size is quite small, almost the same as the Oryza sativa. And uh, we have thanked the Dr. Kurata give us this material number is here, W0106. And we thank Dr. Win, AGI, help us to make the background libraries. And for the back library, because we have a sequence in two different strategies, so for the back library construction, we use the pen that self-pollinate 6 times, and for the whole genome shotgun, we use the next generation 7 times. That's self-pollination 7 times. And for the first background sequence, the total background sequence about 55,000. And before we start, the Dr. Win's lab has finished the backend sequence about 106,000. And later we adapt the strategy called background pool. So our strategy is pool about 30 back in one pool, and the one pool is if you map back to the Nippon berry sequence, that's about 3 megabase, and the smallest one about 2.5 megabase, and the biggest one about 4 megabase. And totally is about 3,000 background and transfer to 100 back pools, and except the chromosome 3 show arm, because show arm have been finished by Dr. Win's lab group. And we estimated the coverage based on the reference it published before, as about in the back pool, we can cover about 84%. And before we start to use this sequence, we have to convince us that actually it's all come from the same area. So we map back to the Nippon berry as a reference sequence. That's showing here that as you can see that the word is too small, but here you can see that in the chromosome 3 long arm we construct the 4, but we pour the 4 pool, and each pool it's almost is position of right position. And for the chromosome 5, you can see that there are several small parts, maybe because of the repeat sequence or other problems, so they are maybe to other place, but generally they are in the right place. And so besides the back pool, we use the whole genome shotgun. And in this part, we like to make some bridge to connect some parts that show read cannot reach. So we send to BGI help us to sequence it in the MapPair library about as the and one we send to AGI to make the 40K because the technology issue. So it has sent to AGI. So it's a 0.8, 2K, 5K, and 40K, 4 different library. And as yesterday night, I got this report that we have finished the assembly in this very preliminary stage. So that's N50 about the 19K and the N90 about the 99K. So I think this not much the progress we have done, and we have a long way to go. That's all. Thank you.